All right, good afternoon. Welcome to another deep dive. If you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I am here this week and the next couple of weeks on the deep dive in place of Scott. Scott is out today, and then he's getting ready to go on a vacation, I believe. And so he'll be gone for the next couple of Friday afternoons, and so I will be here deep diving. If you have never caught the deep dive before, if you don't know what it is, this is a live stream that Scott started where he kind of shows what he is working on each week, and it is primarily focused around CircuitPython because he's the lead developer of CircuitPython, although he has been working the last couple of episodes on the hardware in the loop stuff, which is meant for testing CircuitPython, not like running CircuitPython on that stuff directly. So he's always working on the latest and greatest, whatever's coming up in the CircuitPython world, and whatever tools we're going to be using to validate and test whatever's coming up. I am here. I usually do work at a little bit of a higher level on libraries and projects and things like that. In this case, today I have some sort of library-ish, infrastructure-ish stuff to work on. What is up in the chat to VP Tech Ops? Nice to see you, my friend. So let's finish with the intro for anyone who's new or catching this in the future. If you don't know what CircuitPython is, you can learn more about it at the main website here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. The way it typically works with these devices, you plug them in with a USB cable. It shows up on your computer like a thumb drive, and you can edit a Python code file on that drive. When you save it, the microcontroller will execute the code for you. And inside of your code, you can interface with other hardware peripherals, whatever devices, whatever little bits and bobs are connected to your microcontroller. So some microcontrollers, like these Raspberry Pi Picos, are very general. They just have lots of pins for you to hook up whatever you want. Others are more purpose-built, like a Matrix Portal has a plug for a RGB matrix panel, or this macro pad has some MX key switch slots. It has a display, a little knob there for being a nice little macro pad on your desk. So there are lots and lots of devices, 655 right now, that support CircuitPython. This is not the only way to program microcontrollers, but it is the way that we work on here on this stream. If you would like to help support CircuitPython, one of the easiest ways to do it is by purchasing hardware from Adafruit. This is their website, adafruit.com. They are a hardware and software company based out of New York. They make CircuitPython possible by paying a team of folks, including myself and Scott, to work on it, as well as some others. They also fund all sorts of other open source work that is not directly related to CircuitPython. There's Arduino libraries and other open source things there on GitHub that Adafruit pays people to work on. So if you would like to help support not only CircuitPython, but all of the rest of the open source software that they support, then you can do so by purchasing hardware on their website, adafruit.com, which you can see here. You can get yourself microcontrollers. You can also get yourself all of the extra bits and bobs and add-ons to connect to your microcontroller to make interesting stuff with, like your panels for the Matrix Portal there, as well as all sorts of sensors and lights and buttons and beepers and inputs and outputs and oh my, right? Everything you could think of, basically, you could get yourself there. So huge thanks to everyone who does that. Let me see here. One second. What is this? What is this? Yeah, that's fine. Okay. It's like it's from Ubuntu Core. If anyone's interested in Ubuntu Core, keep an eye on the Learn Guide system. There will be a new Learn Guide coming up next week or the following, most likely, for Ubuntu Core with Blinka. All right, let me just shuffle the windows slightly here, and then, all right, good. What is this one? We don't need, I think. Also Ubuntu Core stuff. Yeah, I don't need this. Okay. So jumping in this week for me, I'm working again on this sort of PyTest integration with hardware in the loop stuff. So I did, I think, mention that Scott's working on hardware in the loop stuff, but he is working, again, kind of at a lower level than I do. He's working on something that will let him, like a rig that's going to let him test core CircuitPython changes. So my understanding is it's going to be able to flash new images. It's going to be able to, at a very low level, sort of like monitor pins and all kinds of things. That is not what's going on here. Here, it's a little bit higher level. It's a CircuitPython device that is actually running CircuitPython. And in my case, it is a ESP32S3 right now, TFT, although I'm not using the display really for anything. And my tests are made essentially to validate the behavior of a driver or to validate some hardware. Essentially, it's like testing both the hardware and the driver. And it gets run right now over web workflow. So anyone who is interested in the sort of prequel to this, you could catch the last couple of streams of mine on Adafruit channel on from Tuesdays, and I think I did also on my channel last week or maybe the week before on Saturday. I was working on a precursor to this. So if this is interesting to you and you want to see the evolution of it, you can go back and catch those as well. But basically, in the newest CircuitPython libraries, like this Max44009, which is one of the newer sensors that we have a library for, there is this folder containing hardware tests. And these are code files that are written to run on the microcontroller, but instead of being like an example or something that you might find in the examples folder, they are meant to be more of a somewhat comprehensive test of the hardware. Now, it depends, like different drivers have different levels of how many things the driver can do. Some of them cover 100% of everything with the test. Some of them cover the most basic stuff. Some of them cover somewhere in between. But the idea here is that these hardware tests are meant to validate that the sensor and that the driver is working as intended. And I have another script. Actually, we'll pull it up in Agent Skills. If anyone doesn't know, Agent Skills, this repo exists under Adafruit. It's not a whole lot of stuff in it, but it's some CircuitPython, as the name would imply, agent skills, so made for LLM agents. But there is hardware test runner is what we want. This one, so hardware test writer. This one, this is actually an agent skill for writing these kinds of tests. But runner has got some scripts in it that kind of integrate these kinds of tests with PyTest, so that you can execute these through PyTest. And what I'm working on is kind of an alternative to that in a way. This is like an automated script that goes through and grabs all of these, runs them one after another, and then gets the full output at the very end, whether they all pass or not. What I think I am interested in now is having a test that can live inside of the repo, which will execute these devices, execute these tests on a device, get the results for each one, and then pass-fail based on that. So rather, like, the agent skill one is good if you're running an LLM agent and you want it to kind of do the tests for you, or like, you know, try to fix something and then continually test after an attempt. But I would like the same thing to be able to be run manually, and then maybe eventually get some kind of test devices set up to where, like, I could have devices that are sort of just on all the time, maybe set up some kind of thing that is automatically updating CircuitPython on them, and anytime there's a change in CircuitPython or one of any of a number of like high-level important libraries, maybe it could run a test suite on that device just to validate stuff is working as expected. That's kind of my grand idea here, which I think is similar to what Scott's after, but he's more interested in the core updates and stuff, right? Like new ESP IDF comes in, I want to test a bunch of stuff. Whereas I'm looking more at the sort of drivers, the libraries, and stuff like that, although it could catch core issues as well. It's just not a full-on like map every pin and you know, have tight control over the whole hardware thing. It's more just like run this code and get the results. So I have this one that's doing Lux. I'm gonna kind of just keep doing these. I do have NeoPixels hooked up, so we'll be able to do that one. One thing I don't have is the servo. I believe some of these might use a servo, although it could maybe be not the case in this one. I'm not sure. We'll see if we come up with it. And if that's the case, I don't have the servo hooked up, so we won't be able to do that one. But I think we can test the rest. So that's kind of what I'm working on, is just adding these here and validating that it's working to be able to execute this code, get the results back, and then issue the pass-fail inside PyTest for that thing. And then after this, I'll move on to another one, because Max 44009 already had these, but I do have a couple of other sensors laid out here, which I think may not have had... So some of them may not have had those tests yet, so we could work on adding some of those if we get all these things working. So next up is mode, though. Mode is going to do continuous mode. CDR, I forgot what CDR stands for. Cool. Is that cooldown? No, is that? I don't remember. What is up on YouTube, my friend? What is this? Naman Sang? Vi? I more than likely mispronounced your name, so I apologize. But hello, and thanks for checking out the stream. I think our talk. Cool down. Continuous. Rate. Anyway, I do think the test should be okay. We're mostly working on this thing, which is running the tests. And I think I'm gonna, so right now the way I'm doing it is I think I'm gonna write one function for each of these. We could, like, there could be a loop or something. The other one kind of collects them all and runs them, but especially since I believe there's gonna be at least one that uses the servo that's not hooked up, I don't want to necessarily just always run them all. Although the other script also did offer a way to run an individual one as well. Basically, all the rest of this is the same. We do need to make sure that it always prints this. And it does. And it should also always print this, which is nice because it makes the thing that's running it return faster. So it makes everything finish quicker. Be able to run that, and it should do 2 tests now. Yeah, collected 2 items. Oh, that's doing the NeoPixels already? Huh. Some tests failed. 9 passed, 1 failed. Fail readings within 2x of each other. I think... This looked like it was making the NeoPixel go crazy. Why was that? Especially because there's no NeoPixel here. Right? Definitely. It's got some of the lights on. What's up, Tithe? Isn't the NeoPixel part of the test like it does Lux against the adjustment? So some of them do, like especially this one down here, the 06 NeoPixel. That one is all built around that idea of using the NeoPixels to measure to make sure that the brightness is getting higher, to check the interrupt behavior as well, to make sure it flips the pin when it goes over under. What exactly am I trying to make, and where can I find more info about it? So I am trying to make a system that lets us run these hardware tests inside of PyTest. So I don't know what is your level of familiarity with CircuitPython and the surrounding stuff. If you don't know anything about CircuitPython, drop another chat in the thing there and let me know, and I'm happy to explain that a little bit more. But if you do already know about CircuitPython, then what I'm trying to do is build out a way to do automated testing on hardware. So I want to be able to run a test on my computer, on my development machine, but that test is actually going to push code to this microcontroller, run the code on the microcontroller, and then give the results back to the PyTest script that's running on my dev machine. And if all the tests that were in that code that pushed passed, then the PyTest will pass. And if some of those tests in that code that was pushed failed, then the PyTest will fail. So that is kind of the main idea of what I'm working on. Specifically, it's on this light sensor, but if I'm honest, this is just one that I had tests for, that I had the device on my desk for. The actual apparatus that's doing the test running and getting the results and making sure that integrates with PyTest correctly, like that's the actual bit that I'm working on right now. I kind of think that this failed because the NeoPixel turned on, because I think it was trying to test consistency and it failed because the readings were not consistent, but the readings were not consistent because the NeoPixels were kind of going crazy. That is very bizarre. It's like when it prints. It's almost like when it prints, it so this I'm not using this, but this is got some SPI stuff on it, which might have chip select connected to the pin, one of the pins I'm using. Could that cause the NeoPixels to wig out? The REPL. Yeah, I mean, I don't know why it would be causing these NeoPixels to be jumping, though. This is really the only thing I could think of. And again, I could just unplug this. I'm not actually using it, but I'm curious. So this is using I2C pins, interrupt, SPI. Where's chip select? Chip select. So I have 10 is on. I can actually tell from this. 9. 10 is on. 10 is supposed to be on the interrupt for this. 9 is actually on NeoPixels. ASCL 5, 6, 9. I'm just gonna change it to a different pin for now and see what happens. What if I just use 10 and whatever comes after it? I gotta get in here a little bit better. Okay, I need a light for my desk. What is the next pin up? Actually, I don't know. Is there an 11? I think there's 11, right? Obviously, I could look at the device, but this makes it so y'all can see what I'm looking at as well. A little easier. It's 9, 10. Yeah, there's an 11. What if we reset now and it's still wig out now that the NeoPixels are actually connected to 11 instead of 9? And it should actually just rerun the same test, because when it runs the test, it overwrites CodePy with it. Yeah, and this time it passed when it just ran because it booted up. Let's run it from here. Yeah. So yeah, see, these are not wigging out anymore, so that consistency test can pass. Okay, and then we get the mode test, and the mode test was all passed as well. Okay, what is CDR? Integration time? Division ratio. All right, so this one is going to... Doesn't use any other hardware, so we should be able to do this with just the sensor by itself. So let's add this to here. I don't know why this thing has always got a mind of its own on the size. Do you need to run the NeoPixels once to have them left on when doing the timing one? I think... well, so there's integration time comes next. This one also does not use NeoPixels yet. Interrupt. This one... This one does not either, but I think that this one is gonna have to... You have to wave your hand in front of it or something. I'm not sure on this one. This one here, though, definitely uses the NeoPixels, and it uses them for a bunch of stuff. It will turn them on, it will make them brighter, it will test the, what you call it, the thresholds for the interrupt with them. Do all kinds of stuff with them, this one will. Let's keep going in order real fast, though. So 2 CDR, let's add one for that. It would, if it would leave the NeoPixels alone and leave a couple of them on, I do think that would not break the tests the way that it was before. I think the reason it broke before is because it, during that consistency test, it, like the first time it took a reading, they weren't on yet, I think, or not as bright or something, and then they started flashing brighter or they turned on, and the next couple of reads were way brighter because they were on. If they would have been on all the reads and just not changed, then I think it would have been okay. But I don't think they're necessary either. Maybe if you're in a dark enough room. In this case, I also sort of have a window nearby that's letting in a lot of sunlight. Why are these all mad? Run code doesn't return anything. That is just untrue. Just not true. If that didn't return anything, then none of this would be working. I don't know, there's a return file right here. I think a return line right there, I think it's... I see. How you do that one? Is it string? This one's probably wrong too, actually. When I said the timing mode, I meant whatever you're running in with PyTest in the terminal. I think that so far none of the ones that I have run need the NeoPixels on. But I do think if the NeoPixels were on and stayed consistent, I think all the tests would still work the same way. That we've run so far, all the ones I've run so far, would work the same way. But they don't have to be on for any of them so far. There may not actually be a servo for this one. I have the whole sort of like servo arm thing that's got this card that it can move over the top of the sensor. Actually, you know, this one probably doesn't have that because it doesn't look like it has proximity. That's the thing. Some of these light sensors, they also have proximity, so they could tell you like how far away a thing is. We might need a longer duration. This one is no, okay, it made it. I feel like it was taking quite a while though. I was worried because if this duration passes before the end of the test, then it will count as a failure. That's actually one thing, one vote for having them broken out as functions like this for each one of these is sometimes these have different stuff in it, so it makes sense to use a shorter or longer duration. Integration. Hard to say duration and type integration at the same time. For hardware and loop testing, I'm really liking the named device thing in Linux where you can access serial ports by, serial by ID. Oh, actually, I haven't seen that one. And it has the full. Let me try this. So this, yeah, for anyone who doesn't know what Todd is talking about here on Linux, all these devices will be showing up as dev something. So like the most basic one would be ACM0 usually for CircuitPython devices, although it could be different depending on if it's got a different kind of serial chip. But there's also this by ID. Oh yeah. And then so if you had multiple devices connected here, you could choose between them, and it's the same thing as here. So this is connecting to serial, which is cool. Yeah, that's a really good point. So yeah, if I was, for sure, when it comes time to get this set up as like an actual just sort of farm of devices that stays on and runs these tests for us, targeting them by the device ID like that will be actually way better. That's a good shout. Yeah, thank you for that. That's a good tip. I knew there was, what's the other one? There's a different buy, right? Buy, what is there? Buy. What's the other one here? Is there, maybe there's not. Oh, okay. Well, I don't TO. That's why we got weird there. By path. Is stuff I don't necessarily recognize. ID. That even tells you what the device is, which is super nice. Yeah. That's really cool, actually. Yeah, thank you for that. Okay. Let's see. So the third one did fine. Let's do integration time. So we're doing this. Let's copy this. We're basically in copy mode here, and most of these have just been working so far. And I do have a USB runner as well. Right now, these tests are going through web workflow for this device, but I do have a USB variation as well, where it saves the file over the normal flash storage, whatever the removable storage endpoint thing is, and then it reads over serial through the USB. This one here, though, it's doing web workflow to both save the code file on the device, and then also it's using the web workflow WebSocket to read back the output. Which I like because I can have the devices. I'll probably do a mix of both at the end of the day, honestly. The ones connected are nice because they could get a new UF2 put on them. But the web workflow thing is nice because there can be a bunch of them connected at a power source that can be on the other side of the room or in a different room or tucked inside of a drawer or something, like out of the way, and they only need power inside there because there's Wi-Fi everywhere. They don't need the USB connection. But I want some connected as well because I do want to be able to have a centralized machine that can update the CircuitPython firmware too on them. Let you do specific ports. All right, here we go. This test. Okay, I was about to say, this test is coming back to me. I think I was getting some weirdness on one of these, now that I'm thinking about it. Yeah, for instance, this was the way, I think I ended up relaxing the, yeah, you can even see it in here, relaxed the stringency of the test, essentially. I think for whatever reason, this 800, I almost said milligrams, 800 milliseconds, for whatever reason on this chip, this time doesn't ever take that long. It goes faster than that. Like this one took 500 milliseconds. This one took 380 milliseconds, 380 milliseconds again. I'm not sure why it doesn't actually get up to 800. The other ones are much closer to reality. So you set it to 100, you get, 92, 89, 91. We got really close to 100. But this one is like almost half pretty consistently. Which is odd. But I did end up accounting for it in the test because it seems to be just how the sensor behaves. The Arduino test and everything else work the exact same as far as I could tell. All right, so integration time. Interrupt is next. Interrupt, this one will be interesting. This is the first one that uses, like 1T there, right? This is the first one that uses other hardware. So it uses a GPIO pin, which I do have wired. This yellow wire here is going to pin 9. Interrupt. Let's make sure this is set to pin 9. I think it should be because I believe that's why I picked it. Nope, it's totally different. Pin 2, which this doesn't even have. What even does have a pin 2? What would I have used that on? Is there a fruit jam? I did do some of my testing on the fruit jam. Anyway, 9 is what we're actually... No, 10. 9 is what the NeoPixels were connected to, and I moved them. 10 is what the interrupt pin is connected to. I think I can... I don't know, how do you run them one at a time? PyTest run specific test function? I need that part. -K. I'm assuming the name of the function. All right, so yeah, there you go. Found 5, deselected 4, selected 1, and it failed. Okay. What did we get here? Some tests failed. 7 passed, 1 failed. The fail was... on this. But the truth is, it's not lighting up the lights, so I don't know why it would go... So partially this is basing its pass or fail on the light level. It could just be darker than when the test was written, or lighter than when the test was written, theoretically. And so we're on interrupt pin tests. That's here. We got a pass when IRQ is disabled. Threshold exceeded. So here it waited for 1 second and then printed done. And then here it would have been expecting the pin to go low, which is the trigger state. Because it enabled the interrupt and it set the upper threshold to 0. The register was correct, though. Just the pin did not change. All right, let's make sure we're wired. Do this right stuff here. B10 is it's down here, SDA SCL 5, 6, 9, 10. SDA SCL 5, 6, 9, 10. I do wonder about the chip select on this thing, though. Maybe this really does actually throw it off. Why don't we get this out of the... Ooh, SD card came out. Why don't we get this out of the mix? See if that makes any difference. Still not going low. So this does set it to input and pull up, is correct. D10. Does it need to take a reading? Or any pending? What is the actual reading? Is it just lux? Yeah. $24. It's definitely above. Oh. I think I have just solved two mysteries at once. The mystery of the blinking neopixels and the mystery of the interrupt pin. It may not be super easy to tell from where the camera's at, but these two wires, these yellow and green wire, these are on the long header of this feather doubler thing here, right? They're not supposed to be. They're supposed to be on the short side because they're supposed to be connected to 10 and 11, which are on the short side of the feather, not the long side. So they're actually connected to SCK, MOSI, somewhere in there, which is why I was blinking, because it was using the SPI bus? I don't know actually why it was blinking. Probably just because it's undefined what those pins do and they probably floated or whatever. Okay, SDA, SCL, 5, 6. We probably can use 9, honestly. SDA, SCL, 5, 6, 9, 10. Don't focus anymore. Alright, yeah, pass this time. So pin went to low because the thing triggered and it was able to actually read it. I don't know why, it just will not focus anymore. Weird. Hmm. There we go. Okay, that one passes. We have, what, 2 more? Threshold and then NeoPixel. And that's it for this one. We are back to no interrupt pin on this one. This should be easy. Just add 5 here. Threshold. Display updates on the SPI bus. Oh, yeah, there you go. We are using SPI because of the display. Totally. Yep. Okay, cool. That one passed. Threshold, easy peasy. And then the last one is the NeoPixel, which does the most interesting stuff because it controls the NeoPixels to test brightness and all, and up and down and all kinds of things. So 9 is what I plugged it into now. And that's fine because it's on the correct side of the little feather doubler there. Actually a tripler in this case, but feathered pinout thing. NeoPixels 6. Is it pixels or NeoPixel? I don't know. Pixel. Okay, it'll probably blow out the camera. Nice. Got it. Cool. But yeah, it runs through the whole like start low time. I think it measures different thresholds for the interrupting. Yeah. And then, so we should be able to just not specify here, and it should run them all. And I did use -s or whatever. There's an argument I passed that's making it print everything out. We could not pass that in, and it would look like normal PyTest, where it's because it's got these like green dots, right? Usually it builds them up. But in my case, it's printing the actual literal output from running the test in between, because I found that easier for troubleshooting it. Suggestion: add the ability to pause before or after a test in the list, so you could add or remove a wire. That would be interesting. Yeah, that would be interesting. Maybe my vision is more for full. Well, I guess my vision goes in two different directions. One of them is this like automated, have some devices just set up, they're always on, they're hooked up to Git or whatever, so they're just checking for new releases of libraries and of the core, and then they're running tests against them whenever there's new ones. So that's sort of one mode. And in that one, I wouldn't want manual intervention, but the other mode is more active. So like maybe I'm doing a PR review, for instance, and someone has submitted a new functionality, or they fixed something internally or whatever. They changed the way some part of the PR review. That one is a more manual thing, right? Because I probably got to dig out the sensor, wire it up, and run those tests specifically. In that case, I could definitely see a world where like an input on each one kind of gave you a chance to like run some tests and then be like, oh, I need to hook up the integration, or I need to hook up the interrupt pin and I forgot to, or whatever, and you still have a chance to do it. This time CDR failed, as did NeoPixel. Int status returns high after status read. We might need to just wait longer. I think I spied a couple of spots where it was doing like time.sleep 0.01. This is at the end of the upper threshold interrupt. Low level, high level. Upper threshold set to this. Settle plus half a second. So like here, okay, it's 0.05, but it did pass a second ago. I kind of think it might just be not waiting long enough. Yeah, we'll see. Let's try the CDR one as well. I don't know how to pass arguments through PyTest. I assume that there's a way where you could pass an extra argument on the command line to PyTest, and then it could like pass that in to here, and then inside of here you could get access to that argument. Because then we could do something like, you know, dash dash pause or whatever, right? And then here it could be like pause is a boolean, and then here it could be like if pause input, press enter to continue or something, right? I don't know for sure if this piping actually exists from argument to like command line argument to function argument, but I imagine that there is something like that, if not the exact same thing. So yeah, I don't know. This time it passed. Try it one more time and see. And then I'll also run CDR by itself. I'm not actually sure what the CDR one, I didn't see which part of the CDR one failed. Nope, that failed again. So even waiting longer, it did still fail. Huh. Did we actually read this? Well, but we're passing sometimes. Interrupt status, we checked back here. Yeah, and as this indicates, checking the interrupt status is supposed to reset the pin. Now, one thing is, though, does the integration time factor in? Like, if you just got lucky, quote unquote, or unlucky, could it be such that you actually have to wait a full integration time cycle to guarantee that it's going to react? It says of the ADC. How about interrupt status? Yeah, I mean, here it does not specify anything about when it goes back. I presume it will say something somewhere. What is up, my friend over on YouTube, and Anta177? Thanks for checking out the stream. So yeah, 0 is off. 1 is detection of interrupt event triggers a hardware interrupt. Pin is pulled low and it sets the bits register bit 0. Wait, it does not say anything there about when the pin would go back to its non-triggered state. And then there's a million of these. Yeah, this is all about when it gets pulled low. So far, I've seen nothing about when it goes back up. There it is. No, but it still does not, it doesn't say. Typical operating sequence. So let's say this. Reads lux from the register 3s and 4s, sets the upper lux threshold to lower lux threshold. Do that. Sets a suitable threshold timer data, works on the tasks until alerted by the pin goes low. That's where the master spends most of the time. When alerted by the pin going low, reads interrupt status to confirm the source of the interrupt was the IC. Guess if you had multiple things connected to the interrupt pin? That's kind of an interesting idea. Takes the appropriate action, then repeat from step 1. But nowhere in here does it say anything about that pin going back high. There it goes. It does say here. Okay. It's reflected in the int pin when the pin, when it's turned on, then interrupt pin gets asserted low. And that is the status. So when the status bit is 1, the interrupt pin goes low. When the status bit, it says when the status bit is set to 0. And then, here it goes on to say, once this bit is set, it can be cleared either by reading the status register or by writing a 0. So disable the interrupt or read the status. But it doesn't say anything about the timing, really. And I'm just wondering, since the integration time goes up to like 800 milliseconds, could it be the case that that is actually the same sort of cycle that this could be on? It might take up to that. I mean, it would be weird that it was passing sometimes. Well, but we also saw the integration time when it was set to 800 milliseconds was actually more like 300 to 400, so... or go with programmable switch in the hardware and loop setup to allow setting the switch on and off. That would allow you to run a test with a missing interrupt, etc. Or do a soft or hard reset. Yeah, like a way to sort of skip a test or something. Huh. Status set. So let's check if this is going back to false. Oh, you know what could be the case, actually? Could it just be re-triggering? But then why does it pass sometimes? I think the lights were still on. Status is true. Maybe it tripped again. We went above the upper, so let's read through the logic here. The upper threshold is set to this. We got a low level of 1,000, a high level of 12.5. Upper threshold is set to basically halfway in between, 7,300. Int pin, so test, and we would be on pixels of what? Right now we would, theoretically we should be back here on pixels of 20. Brightness, I believe that is. We get into here, we check the interrupt value. We check the interrupt status, because I guess we believe that we should be below the status currently. We set the pixels to high, maximum brightness. We wait so that the sensor has, there's where our integration time waiting I think probably matters a little more. We check the, we get the pin value of the interrupt pin, we make sure, we print it, we make sure that it's false because we should have gone above the upper threshold, so the interrupt should have fired. We validate that the status is also true, we sleep. We're checking this again now. Here it's going back to high. Well, it's validating that it returns to high. But the lights are still on. So whenever this clears, it just instantly re-triggers. Because the lights are still on at full brightness, and the threshold is still set to half brightness. Past when it did. That I do not have an answer for anymore. I think what we would want to do is set the brightness to off before we read the interrupt status. Because I think it would stay triggered. In any case, we are just about at time here, so I am going to wrap it up in just a minute. If anyone has questions, comments, or last minute thoughts, now's a good time for them. If you are interested in CircuitPython and more of me working on CircuitPython, you can find me on Tuesday mornings here on the Adafruit channel, 10 a.m. Central Time. I stream here working on CircuitPython stuff as well. And like I said at the top of the stream, I will be around for the next couple of deep dives as well. So this is the first one I'm doing, the next two as well, I believe. So June the 12th and the 19th. I will be back for deep diving here Friday afternoons, 2 p.m. Pacific, 5 p.m. Eastern. That's usually how Scott builds it. But I am in Central, so I usually say 4 p.m. Central. Any thoughts on the embedded space, on AI in the embedded space? I would say right now, I think like there's room for some interesting things to be done with AI on embedded devices, but I think right now a lot of it is kind of gimmicky and not necessarily super duper useful. There are some interesting projects out there where you can use AI and LLM or something like that to kind of like control the microcontroller's pins and stuff, and those are kind of cool. There's like ESP Claw, which is sort of one of those, but my main gripe with a lot of these sort of AI on embedded microcontroller things is like, truthfully, I don't really see the need to run an agent loop on an embedded device like a microcontroller. In my mind, a microcontroller should have like one sort of more specific purpose once it gets programmed to do whatever it does. It's not really a generalist device that should have an LLM agent running inside of it, in my mind. What I'll leave you with here before I sign off, where I see embedded add-on devices. So you have your LLM agent, it runs Claude Code or PyDev or whatever one you use, Codex, there's a bunch of them out there now. Whatever one you use, you have that. It runs on your computer, and then you have another device, a microcontroller device that's hooked up to that computer. It's either hooked up with a USB cable, it's hooked up over the network with an HTTP server, or with Adafruit IO, mini MQTT. But it has a channel to communicate with that device, and it has a predefined set of communications that are like, ask that device to do this, or ask that device to send back the data from the sensors or whatever. So check out this Learn Guide if you haven't. This is my Learn Guide from last week, LLM Agent Embodiment Kit. This is the kind of device, what I call it kind of this like sidecar device idea, where it's made for an AI thing to interact with, but it's not made for the AI agent loop to run inside of this. Instead, this is just like a peripheral that the AI agent has access to control. That's, right now at least, the kind of stuff that I think is more interesting personally than the agent inside the embedded thing. Good question, by the way. Yeah, thanks for throwing out the question. All right, that is going to do it for today. Like I said, I'll be back next week, Friday, 5 p.m. Eastern, 2 p.m. Pacific. I will be here for Deep Dive, as well as Tuesday, 10 a.m. Central Time here on the Adafruit channel. I hope you all have a wonderful rest of your Friday and a good weekend. I will see you back here next time.